Hi guys, I am Divyang from IGCSE on fingertips, and today we are going to discuss a predicted paper for 2024. Now, when I say predicted paper for 2024, I mean that I have gone through the past papers, tried to find a pattern and kept the questions that I feel may be asked similarly in your Feb, March or ON 2024. So let's get started. We have the physics paper first, and the first question is figure 1.1 shows seawater flowing down a channel into a tank without splashing. The water is flowing at a rate of 800 kilogram per minute. The length and width of the tank are 3.10 meter and 1.20 meter. The density of the seawater is 1020 kg per meter cube. Initially, the tank is empty. Calculate the depth of water in the tank after 1 minute. Give your answer to three significant figures. So what I will do first, see what has happened is they've given that the flow rate of water is 800 kg per minute, and they have also given us the density of water, right? If we have the density of water and we have the flow rate, what can we do? We can find out how much water has flown, right, in 1 minute. Then we will find out that what will be the volume of this much water. From that volume, I already have the two dimensions. So can I find the height of this water? I definitely can. Let's find out. Okay, let's try it over here in this space. So first I will say that 800 into 1, right? The mass of water will be 800 into 1. So 800 kilogram of water has flown into the tank. Now that the volume of tank will be 3.10 into 1.20 into the x. But can I say that instead of volume, right? Can I say 800 kg, or rather also our board prefers that we write the formula first, then input the values and then make the required value the subject of formula. So try to write the formulas first. Volume is equal to, or rather we should actually write density is equal to mass upon volume, and I want to find volume, which is equal to mass upon density, right? So mass upon density 800 divided by 1020. You can find the value of x now by writing it as 800 upon 1020 multiplied by 3.10 multiplied by 1.20. Let's quickly do this in our calculator. So we have 800 divided by 1020 multiplied by 3.10 multiplied by 1.20, which we find as 0.21 meter. Okay, the depth, so we have 0.21. They have said three significant figures, so 0.21 meter, right? Don't forget the units. That is your answer. You have to show all of that working over here, guys, right? For me to look at values, I have done it somewhere else. The height of the water decreases by 0.420 meter as it flows down the channel. Calculate the decrease in gravitational potential energy of water each second. Now, I know that gravitational potential energy is equal to mgh, and I can say that the change in gravitational potential energy is equal to the change in height. From here, I will write the mass of water that flows is 800 multiplied by the gravitation. We will take 9.8, right? Previously we used to take 10, and the height we will take as given 0.420. So let's multiply that now. So we have 800 into 9.8, 0.420. We find that this is equal to 3292.8 joules, right? Can I write this as 3300 joules? I should write this as 3300 joules because most of the things given to me are given as two significant figures, right? Two or one significant figure also exists, but two is okay, right? Okay, then what do we have? Water stops flowing. The depth of the water in tank is 0.800. Calculate the pressure at the bottom of the tank due to water. We know that pressure is given by dgh, right? This can be written as density is 1020 given in the first part of question. G we have to take 9.8. This is given in the first page of your question paper, and the height is 0.800. Again, so we have 1020 into 9.8 into 0.800. We find the answer is 7996.8 Pascal, right? Do not forget to write units. So I will write 8000 Pascal is my answer. Due to water they have asked, here they can trick us that they can write calculate the pressure at the bottom of the tank or calculate the total pressure at the bottom of the tank. In this case, if that was given, you would add 10 to the power 5 Pascal. This is nothing but atmospheric pressure. Here you don't have to use this because due to water, right? In case if you had to find total, you would use that method. Now, next question we have, define the moment of a force about a point. The force multiplied by perpendicular distance from the pivot. Now, generally in your textbooks, at the end of your textbook, you would have definitions, or you can actually go through a lot of mark schemes and try to make a notes of your own definitions. There are very few definitions that are repeatedly asked, so you can do that, right? Then what do we have? Figure 2.1 shows a uniform rod of wood suspended from pivot. The rod is held stationary by a horizontal force F acting as shown. The mass of rod is 0.080 kg. Calculate the weight of the rod. W is equal to mg, which is equal to, guys, even if you are very smart and you know your answers, try to write the formulas always, okay? That will make sure when you are rechecking the paper that you've done the correct method. So we have 0.080 multiplied by 9.8. So let's find out what will the weight be. 0.080 multiplied by 9.8. We find it is 0.784. So can I write this as 0.78 Newton? Correct? Weight is measured in Newton. Then what do we have? The moment of W about the pivot. What is the distance of W from the pivot? Let's find out. See, this is the pivot, right? And this is the perpendicular distance. In the definition above, we have written that it should be perpendicular distance. So this is the perpendicular distance. So I will have to multiply it with 0.25. I'll write 0.25. So here again, moment is equal to force into distance, and this could be written as 0.25 multiplied by 0.78, right? So 0.78 multiplied by 0.25 gives me 0.195 or 0.20. Moment is in Newton meter, right? This is measured in Newton, this is measured in meter. So Newton meter is my unit. The moment of F about the pivot, it should be equal and opposite. How can we guess or how can we know it is equal and opposite? Because they are saying that the rod is held stationary. What are the conditions for equilibrium? The total of forces must be 0 and the total moments about the pivot must be 0. For the pivot moment to be 0, the moment due to F should be equal and opposite. They are asking for magnitude. So I can write equal magnitude over here, right? So I will say that this is nothing but 0.20 Newton meter. Then we have find the force F. To find the force F, we'll have to find out what is the distance of force F from the pivot P. Do we have this distance? No, we don't, right? Sorry. This is the distance, correct? We don't have this distance, but this is also the perpendicular distance from pivot. We can definitely use this. So we have 0.75 multiplied by the force F, right? Or let's write like this, that moment is equal to F into D, and we have 0. We have M, which is given 0.20 is equal to F into 0.75. Can we find the value of F from here? So we have 0.20 divided by 0.75, which gives us 0.266, right? So I'll write 0.27 Newton, nearly 0.27 Newton will be your answer. Then the angle between the rod and vertical is increased. Now, just for our understanding, this is W, this is F, and this is the pivot, right? Angle between the rod and vertical. So this is the vertical, this is the rod, and this is theta. If this theta is increased, state whether the force F needed to hold the rod stationary must be increased, decreased, or stay the same. So what will happen? They are saying that if you take it over here, what happens to F2? Is F2 equal to F, or F2 greater than F, or F2 is less than F? To understand that, see, we want to keep the rod stationary. To do that, now what has happened? The distance, perpendicular distance from the pivot has decreased. If the perpendicular distance from pivot has decreased, then greater force is required, right? Because the moment is still saying the same. Actually, if you think about it, the distance of weight, the perpendicular distance of weight is increasing. Therefore, you have to say that the moment increases, but the distance decreases. So the force required to keep it in equilibrium must increase. Okay, so let's write it down. The distance of W increases. The distance of W from pivot increases. The moment increases, but distance of F, or perpendicular distance, right? Perpendicular distance of F from pivot decreases, hence F must increase to keep the forces balanced. The not forces, to keep the rod balanced, right? Or stationary. That also works. Now, third question. A ball of mass 15 gram is glued to a straw. The straw is threaded onto a horizontal string as shown in figure 3.1. The balloon is filled with air and then air is released. So air will be released in this direction, equal and opposite moment will be applied in this direction. Ideally, the balloon should move forward. As the air leaves the balloon experiences a force. The balloon accelerates from rest until it reaches a constant speed, then travels 0.67 meter in 0.18 seconds at this constant speed. Then what is the question? Explain in words what is meant by the term impulse. So I have impulse is the change in momentum, right? Or force into the time it takes to apply this force. Then calculate the resultant impulse in the balloon while it is accelerating. So what I will do, I've just said that impulse is change in momentum. So can I write the change in momentum is mv minus mu. Now because it accelerates from rest, can I say the initial velocity will be 0? Can I find out the value of v? I can say that v, final velocity, is distance upon time, because it is moving at constant velocity during this 0.18 seconds. So 0.67 divided by 0.18. We have 0.67 divided by 0.18. We get 3.72 recurring. So now we have the velocity. What is the mass of this balloon? I suppose it was 15 grams. Yes, it is 15 grams. So what I will do, I will say 15 into divide by 1000, because this will be measured in Newton, right? So divide by 1000 multiplied by 3.72. And because this initial velocity is 0, the value of m into 0 is 0. So I have 15 into 3.7222 whatever divide by 1000. So I find that the impulse is 0.05583 recurring. So what I will do, I will say that this is 0.056 Newton meter, right? Or because I have used change in momentum, I can write kg meters per second. This is a better unit, okay? Because we have used velocity for our calculation and mass, we should write kg meter per second. Explain how momentum is conserved as the balloon accelerates. The air, I've just told you when I was reading the question, air escapes in this side, balloon moves on right hand side. The air moves with same momentum, right? They have asked how is it conserved, so we should write that it has same momentum but in opposite direction, right? Same momentum but in opposite direction. The total is 0 as it was at the start, right? We started with 0 momentum. If momentum is conserved, the total momentum finally also should be 0, and this is how it is 0, right? Then we have figure 3.2 shows the direction of two forces acting on different balloon as it moves. Determine the magnitude and direction of the resultant force on the balloon. So what will I do? I will say that this force is 0.40 and this is 0.74. I need to draw a trapezium, or I can also, sorry, not trapezium, a quadrilateral, which is a parallelogram, or you can draw a triangle, because quadrilateral is easy. First I need to find a scale, right? I cannot draw 0.74 Newton, I have to draw it in centimeter, and I want my lines to be at least 4 centimeter long. Okay, so can I simply say that scale, right? You will have space for writing that down. I'm just writing it here so that I can look at values simultaneously. Scale is equal to, scale I can write as 0.10 Newton is equal to 1 centimeter. That means this 0.40, right, should be how much? It should be 4 centimeter, correct? Now at 90 degree, what should happen? This should be 0.74, or because it is in centimeter, it should be 7.4, right? Let's draw a line of 7.4 centimeter. This is a line of nearly 7.4 centimeter. Now what you should do, you should actually see, this was not even 90. I think you'll have all the tools and the time to answer this question. What you should do, now you should measure how much this force is, right? Also draw arrows like this, guys, right? And oh, I'll have to draw parallelogram. Sorry guys, just a second. I have this option. I don't think you would. Okay, after you are done with this, what you should do from, so I have a rectangle over here. You might have a parallelogram that all sides may not be 90. Why are the sides 90 for me? Because these two forces are at 90° to each other. Let's draw the resultant force, or rather, this should not be my resultant force. What should be my resultant force? It should start from the common side. Okay, it should start from the common, or just a second guys. Right, after so much time, I think I've almost got the answer. It's 5.75 for me, right? So I'll say 5.75 centimeter is equal to how many Newton? It's 0.575 Newton. Don't write this 5, right? Just write 0.57 Newton. So the magnitude is 0.57 Newton. Direction resultant relative to the horizontal force. Let's find out how much is it. Okay. Actually, I think we'll need to, yes. Okay. Resultant to horizontal, correct? 30° nearly. So I will write 30° as my answer. If you draw it more accurately, you can find that it might be 30 or 31. But yes, this is the answer, right? I hope you got it, how to draw this parallelogram or rectangle in our case, right? These type of questions are not asked in every exam, but this was not asked since I think 1 or 2 years. So I expect these type of questions to be there in your paper. Explain in terms of the momentum of particles how a gas exert pressure. So I will write particles collide and their momentum changes, which produces force on the walls of container with an area exerting pressure, right? So change in momentum, force, and this force per unit area is pressure. Those are the keywords over here. The temperature of a sample of gas is increased at constant volume. State and explain any changes to the pressure of gas. The pressure of gas increases. Why will the pressure of gas increase? And the question is asking both of the things. They are saying state. So I have stated the pressure of gas increase. But to state correctly, I must know why does it increase. Now what happens? You've just written that particles collide and their momentum changes. So when I heat gases, what happens? Their average kinetic energy increases. What does that mean? Their velocity increases. If their velocity increases, it is obvious that their change in momentum also increases, right? Let's understand this. Let's say the velocity is 10 right now and the particle was going like this. It collides with the wall. Sorry, it should go straight, right? Yes. So the particle collides with this wall over here and returns. Let's say its velocity was 10. So it went from 10 to minus 10. The change in momentum is 20 multiplied by the mass of the particle. Let's say because of increase in temperature, the velocity is now 15. What will happen? It goes here with 15 velocity, returns with minus 15. The change is now 30. So if the velocity is greater, the change in momentum is also greater. If the change in momentum is greater, force is greater. If force is greater, pressure is also greater. So state and explain any changes in the pressure of the gas. The pressure of the gas increases as velocity increases, that increases the change in momentum, right? We don't need to write the whole story. Change in momentum and hence pressure. If you write only change in velocity, because temperature increases velocity and change in velocity changes the pressure, that is also okay, right? Let's look at the next question. Another sample of gas is sealed in a container of volume 170 centimeter cube and exerts a pressure of 9 into 10 to the 4 power 4 Pascal. The volume of the container decreases by 70 at constant temperature. Calculate the new pressure of the gas. So what we will do? P1 V1 equals to P2 V2. Now guys, here they have said it is decreased by 70. What happens generally? We look at values. We'll write P1 is 9.0 into 10 to the power 4 multiplied by 170 upon, because this is in centimeter cube, I need to change this in meter cube, 100 cube is equal to, we have 70, unknown pressure P, unknown pressure P2 multiplied by 70 upon 100 cube. This is incorrect. They are saying it is decreased by 70, not that it changes to 70. Okay, so let's quickly get to that. Just a second, let me erase this properly. Right, so I have the pressure P2 multiplied by, it decreases by 70, so becomes 100 upon 100 cube, right? Now I have 9.0 into 10 to the power 4 into 170 upon 100 cube multiplied by 100 cube upon 100 is equal to P2. So what P2 will be? Let's find out. 9.0 into 170 divided by 100. I have 15.3. So pressure is 15.3 into 10 to the power 4. See, board prefers you write 1.5 into 10 to the power 5 Pascal. Board prefers that you write it in the form A dot B into 10 to the power C units, if there are units for that answer. So try to write in this form, right? This 100 cube and 100 cube gets cancelled. So on both the sides, if you have same units, you don't actually need to add conversion, but I have to make you understand that why it is required. Okay, so now we have next question. Figure 5.1 shows an aluminium block after leaving a furnace in a factory. Okay, the mass of block is 1200 kilogram and it is heated in the furnace from 20 to 380 degrees Celsius. The aluminium block does not melt, so its melting point is much higher than that. Obviously, it's a metal. The specific heat capacity of aluminium is 960 joule per kg degree Celsius. Okay, right? Calculate the thermal energy gained by the block in furnace. We have all the values we require here. So the formula is H is equal to mc delta T. What is the mass of the block? 1200 kg. What is its specific heat capacity? 960 joule per kg degree Celsius, right? So this is given in kg, and we have the change in temperature 360 degrees Celsius, right? 380 minus 20, so 360 degree Celsius. So this degree Celsius and kg can get cancelled out. Why am I doing this? To show you that the units will be joules over here, not kilojoules. Okay, you'll write 1200 multiplied by 960 multiplied by 360. The answer over here is 4147200000. Now you can just press the ENG button on your calculator and find out the 10 to the power you can write. For me it is 4.1 into 10 to the power 6, 7 and 8 joules. Okay, this is the thermal energy gained by the block of this aluminium. Figure 5.1 shows a factory worker standing 3 meters away from the block. State and explain the main process by which thermal energy is transferred to the worker. Now, keywords of the question: state and explain, just like that pressure question. Let's see. If he is standing 3 meters away, the air is, after being heated from the aluminium block, it rises, right? So convection is no way the answer. Conduction cannot happen because he is not touching it. So the only answer is radiation, right? The answer is state. So radiation is the process. And explain the main process. What do you have to explain? The radiation, right? So radiation is when the heat travels, or thermal energy travels, from hot object to cold object without the need of any medium, right? You can add that he is standing far away, so no conduction or convection can take place, but that is already stated in the question, so I think this is okay. Then we have state and explain the main process by which thermal energy is transferred from the outer surface of the solid metal roller to the interior solid metal rollers. So these are the rollers. This is the block of aluminium. Heat is transferred from the exterior to the interior. The electrons state and explain. So first, shall we state the answer? The thermal energy, let's write thermal energy in this answer. The thermal energy is transferred by conduction, right? The electrons move from exterior to interior, and vibration of metal atoms goes from exterior to interior. I think my handwriting are readable for you. Okay. Then we have the next question. Define specific latent heat. Again, I'm telling you, you should make a list of the definitions and try to look them up either in your textbook or in your mark scheme and find out if it is the correct definition or not. Heat required to raise the temperature of 1 kilogram of an object by 1 degree Celsius. You can also write 1 Kelvin, the change in 1 degree Celsius, and 1 Kelvin is equal. Explain the melting of a solid in terms of molecules and energy. When the solid gains heat, right? They've asked molecules and energy. So gains heat, energy. The molecules start vibrating more and finally have enough energy to overcome the intermolecular force and the solid melts. Right? The particles can now move away and therefore the solid is melting. Let's see what is the next question. Next question is, an electrical heater is used to heat a liquid to its boiling point. Okay. Figure 6.1 shows the apparatus when the liquid is boiling. So we have 3800 grams of liquid. The heater supplies 1.26 megajoules. Mega is 10 to the power 6 joules of thermal energy. The mass reading shown on the balance decreases from 3200 to 2300 gram. Calculate the specific latent heat of vaporization of liquid. Now, what they have done, when the liquid is boiling, so only during boiling, so the heat energy supplied is mass into the latent heat of vaporization. How much heat is applied? 1.26 into 10 to the power 6 megajoule. What is the mass? Mass is 3800 minus 2300. So this is 1500, or rather I would write 1.5 kilogram, and we don't know the specific latent heat of vaporization. So this will be 1.26 into 10 to the power 6 upon 1.5. Let's find out. So we have 1.26 divided by 1.5, simply I get 0.84. So can I write 8.4 into 10 to the power 5 joules per kg, right? This was in joules, this is in kg, correct? If you wanted to write it in megajoules, it is 0.84 megajoules per kg. That is also correct, but this is the best standard form. You can write your answer in with correct round off. State and explain precaution to improve the accuracy of the value of specific latent heat calculated in B. Now, if you observe, guys, there is no insulator on the container. So what I will write? I will write add, state and explain, right? So add an insulator and add an insulator that helps in decreasing the heat losses to increase the accuracy of the experiment. Then what do we have? Light. Okay, figure 7.1 shows a ray of light approaching the face AB of glass prism of refractive index 1.5. On figure 7.1, accurately, when they say accurately, you may require to do some calculations. Draw the path of the ray within the prism from the face AB to face AC. You will need to make a measurement and carry out a calculation. This is a 4-mark question. So what measurement should we make? We should actually make the measurement of the angle of incidence, right? The angle of incidence. So let's say, okay, let's find out what is the angle of incidence. So between this and the 90 degree, right? You don't need to draw the 90° as of now. In pen, it is better if you can. So I'll write angle of incidence is 60°. And they have given refractive index is 1.5. I know that refractive index, you can do this calculation over here. So let's do that over here, right? So we have n is equal to sine I upon sine r, which can be written as sine r is equal to sine I upon n, and r is equal to sine inverse. You'll find this mathematical function in your calculator, on your calculator, right? Sine inverse of I upon n. So let me quickly do that. So we have, you can press shift and then sine, it will give you sine inverse, right? Sine I, also input the values. So we have sine inverse into sine 60 upon 1.5. So sine inverse of sine 60 upon 1.5. We have, okay, it is saying math error. Have I added any incorrect value? Let's see. Divide by 1.5. It is in degree. Sine inverse answer. Okay, I don't know what happened, but now it's saying it is 35.26. Now they are asking accurately draw 35.26. That is not possible. I can accurately actually only draw 35, right? Because it is 26, I would prefer that I draw an angle of 35, not an angle of 36. So this is my normal, and the angle I have to draw is 36. So quickly, because I have this type of protractor, 90 minus 35, 55. So if I find it at, acha, oh no, this is a smarter protractor, guys. Okay, so it is right. So we have this. I think if you just erase this line, if I just erase this line over here, so this will give me the correct answer. Okay. Okay, guys, I hope that you got how do you draw this. Also, a small mistake that could have, taken away 4 marks, but please don't draw it beyond AC. Okay, another surface, one more diffraction. Let's see what is the next question. Determine the angle of incidence of this ray when it strikes the face AC. Okay, determine the angle, right? How would you determine the angle? By actually letting it be there, right? Okay, what should I have done? So this is the angle. Let's measure it, guys. I think this is taking too much of our time, but anyway, let's measure it. Okay, let's find out. I think this is the maximum angle we can go for. Okay. Okay, guys, I'm estimating that this angle is 90 minus 76, right? You'll have a protractor, you'll obviously have a better tool. 90 minus 76, what would that be? 14. So I will write 14 degree, right? Not Celsius, guys. Okay. After taking so much time, they have, without further measurement, sketch on figure 7.1 the approximate path of the ray passing through the face AC. What will happen? It is going to refract away from the normal, right? You should draw normal. I have not, but you should draw normal, guys. So this is definitely not the normal. It should be perpendicular, right, to the face. So that is the normal, and this somewhere will be your refracted ray. Okay, let's now go back to our question. Next question, we have figure 7.2 shows a ray of light traveling within an optical fiber. Complete the path of the ray of light to the left hand of the fiber. So I believe if I take this as the angle of incidence, right, this as the normal, this as the angle of incidence, then this will be the angle of refraction, and again this will be the second angle of refraction, right? We have to take care of the fact that angle of incidence is very high. Name the process taking place at x. It is total, don't write TIR, okay, total internal reflection, not refraction. It is going back in the same medium. It is reflection. Now, the truck driver wears spectacles to correct long-sightedness. Figure 5.3, 7.3 shows how a blurred image of an object forms on the retina. Any effect of the cornea on the rays of light can be ignored. On figure, this one figure, draw how long-sightedness is corrected by adding a suitable lens in front of the eyes. Now what is happening, guys? The image is not forming properly here. Why? The rays are not converging from the lens to the required degree they should be. So the lens that we add should be a converging lens. It has to help in converging, right? So the lens that we add should be converging. Now take your scale and try to draw this diagram carefully. Continuing the path of three rays until they meet to form an image. So what you should do, you should draw straight lines till here, then show a little bit of convergence till the next lens, and then show finally convergence where the light rays can meet at the retina like this. My lines are not straight, but I think if you have a proper tool, you can draw straight lines and answer this question. See, this simple question is for 4 marks, right? So with this, you should also be making a list of things you should carry to your exam. I have a lot of kids who come without protractor to give a test of light, to give a test of forces, right? Please don't do that, it's your board exam. Figure 8.1 shows an incomplete electrical circuit. A student completes the circuit and measures the current in the 6 ohm resistor. On figure 10.1, draw an ammeter symbol in the gap and straight lines to indicate wires in other gaps to show how the student could do this. So here there must be wires and here must be the ammeter, right? Now why can't ammeter be in either of these connections? Because it will then measure current only across the 2 ohm or 4 ohm resistor. The student wants to measure the current through this. So here it splits, but here it is equal to the current in this branch, and therefore ammeter should be added over there. Then a voltmeter is connected to measure the potential difference across the 4 ohm resistor. On figure 10.1, draw voltmeter symbol connected in the correct position. So if I want to measure across the 4 ohm, I will connect a voltmeter in parallel. Always remember, ammeter in series, voltmeter in parallel. Then we have, when the circuit is complete, the current in 2 ohm resistor is 2.5. Calculate the current in 6 ohm resistor. So instead of doing all the calculations here, I will be doing calculations just in this space, right? Because I need to look at the values and explain simultaneously. So they have said that here the current passing is 2.5 ampere. What will be the current passing through 4 ohm resistor, and then this current combines and passes through the 6 ohm resistor. Now see, because both of them are in parallel, they have the same voltage across them. So V1 equals to V2, right? And we know that V is equal to IR. So can I say I1 R1 is equal to I2 R2, which can be written as I1 upon I2 is equal to R1 upon R2. We know the value of I1, it is 2.5. We don't know the value of I2. So, wouldn't it be better if we do this, that before we add these values, I write over here that I2 upon I1, or rather I2 is equal to R2 upon R1 into I1, right? Then you have R2 for R1 2 into I1, which is 2.5. So 2 times of 2.5, I will have I2 is equal to 5 ampere, and the total current is 2.5 plus 5, which is equal to 7.5 ampere. This is your answer. Okay, so this is how you find this. Then let's see, do we have anything else? No, we don't. Then we have figure 8.2 shows same electrical circuit with an alternating power supply and a wire in the gap AB. Draw a diode symbol in one gap and a straight line to indicate wire in the other gap, so that the current from right to left, in the 4 ohm resistor and alternating current in 2 ohm. See, if I want alternating current in the 2 ohm resistor, the wire goes here. So in both directions current can pass. I want current from right to left. So if I want current from my right to my left, I should draw the arrow of the diode in that direction. So this is your diode. You can find circuit symbols in your syllabus booklet as well. You don't need to go through textbook and write down the each circuit symbol. In your syllabus book, you will find all the circuit symbols that you need to remember. Okay, so that is 2 marks there. Then we have next question. It says the magnitude of a charge on beta particle is 1.6 into 10 to the power minus 19 coulomb. State the proton number and nucleon number of alpha particle. What is an alpha particle? It is nothing but the nucleus of helium. So proton number of helium is 2, nucleon number of helium is 4. Determine the magnitude of charge on alpha particle. It is, so they have given this is 1.6. So magnitude of charge in an alpha particle is 2 positive. So that should be 2 multiplied by 1.6 into 10 to the power minus 19. But here it is negative charge. On alpha particle it is positive. So I will write 3.2 into 10 to the power minus 19 coulomb. They are not asking relative charge. They are asking the actual value of the charge. Right? So don't write 2 over here. You have to write 3.2 into 10 to the power minus 19. A nucleus of radium-230 consists of 880 protons. Okay, so we have radium-230 and it consists 88 protons and 142 neutron. Radium-230 is radioactive and decays by beta emission to an isotope of actinium. The symbol for radium is Ra, the symbol for actinium is Ac. What is happening? Beta, right? Beta emission has a charge of -1, but it has 0 mass, right? And 0 atomic number, only the charge of -1. So what should happen to actinium? Just a second, what happens in beta decay? Okay, I remember this now. Right, the neutron number decreases by 1, but the mass number stays same. So 89, the proton number increases by 1, mass number remains the same, neutron number decreases by 1, proton number increases by 1, mass remains the same. In beta negative decay, what is happening is a neutron splits into proton and electron. This electron is given out in the form of beta decay. So this is your answer. This is for 3 marks. The half-life of 230 radium is 93 minutes. A sample of radium contains so many grams of radium-230. Calculate the mass of radium in the sample after 279 minutes. So first we need to find 279 minutes is how many half-life. To do that, I have 279 divided by 93. So there are 3 half-life. So the sample of radium is halved 3 times. So I will simply write 9.6 into 10 to the power minus 12 upon 2 raised to power 3. So simply 9.6 divided by 8. That will give me 1.2 into 10 to the power minus 12. Right? Calculate the mass of radium in the sample. So radium was this much and then it decreased 3 times to its half, resulting in 1.2 into 10 to the power minus 12 gram. Sometimes they change this question and they say, what is the mass of radium that decayed? In that case, you cannot write this answer. In that case, your answer should be 9.6 into 10 to the power minus 12 minus 1.2 into 10 to the power minus 12. I am telling this to you because I am saying that this is a predicted paper. What if they change the question a little bit? What if they ask some variation, right? We expect this to be asked, but obviously we have not seen the paper. So you write the difference of this answer in your difference of these two values as your answer, right? And then we are to the latest addition in the syllabus, the new topic. The time taken for Mars to orbit Sun is 690 Earth days. The average orbital radius of Mars is 2.28 into 10 to the power 8 kilometer and Earth day is 24 hours. Calculate the average orbital speed of Mars in kilometer per second. The average orbital speed is 2 pi r by t, right? So we have 2 pi. They have given the radius is 2.28 into 10 to the power 8 kilometer. We don't need to change anything over here, but this says 690 Earth days. So days is 24 hour, 24 hour to 60 minutes and 60 minutes to 60 seconds. If you calculate this, you have 2 pi into 2.28 into 10 to the power 8 divided by 690 into 24 into 60 into 60. We have 24 kilometers per second. So the actual answer is 24.02, but I'll round it off to 24 kilometers per second. State the shape of orbits of the planet. Elliptical, right? It's not complete circular. Then light from a distance. Okay, should not have done that. Right. Light from a distant galaxy is red shifted. Explain what is meant by red shift. The change in the frequency of light towards the red side of the visible spectrum. So when light is coming from distant galaxy, what happens is its wavelength is perceived to have increased, its frequency is perceived to have changed. Now that change happens towards the red side of the visible spectrum and that is known as red shift. This is due to Doppler's effect, right? Don't need to write this Doppler's inside the answer. State the quantity that the redshift of a galaxy is used to calculate. The redshift of the galaxy can be used to calculate the velocity, the receding velocity of this particular galaxy that is going away from us, right? With this, the paper is over, guys. Now, obviously, this is not a paper that I have seen from the board. I have, taken from some vault of the board and given it to you. No, this is a general idea that I expect the paper to look something like this. Similar concepts can be asked. So if I did help you, then after your exams, please come and let me know in the comments that what was asked. Was it similar? Was it not? And when I make another paper for Feb March, I know that what changes I need to make. Thank you guys. Bye bye and all the best for your exams.